really quick to the page that we finished the other day just to relook at the instructions, for example, too, because I realized there's a B, but it doesn't. It's like two separate problems altogether, but I just wanted to refresh on what the actual instructions said. So consider each situation described, identify the population and the sample, explain what P and P hat represent, and tell whether the methods of this chapter can be used to create a confidence interval. So we had done that one. So here's part B. Which, like I said, is just a completely different problem altogether, but just for the purpose of seeing what it wants us to do. What percent of college students have cell phones? 2,883 students were asked as they entered a football stadium, and 243 said they had cell phones with them. So what is the population? So, like, what's, like, the big group that we're looking at? Yep, college students. Then the sample is what?
College students in the stadium.
Yeah. And we could probably say, like, specifically the 2,883 just to have that there for reference to know exactly what we're talking about. So P is our population proportion. So the P that's by itself is going to be the proportion of all students with a cell phone.
When was the survey? Because there's no way this would be true now.
I would say, based on when our book was written, probably in the 2010s.
Dark times.
But also, this says that they had them with them. So, like, they may have just not taken it. Like, because, like, it's kind of, like, hard to say. Like, I wager they would have most of them would have had one. But, like,
Yeah.
It could have even been, like, the earlier 2000s, because a lot of people had the flip phones that didn't have cameras. Or, like, even the slide phones didn't necessarily have cameras.
Yeah.
So, like, there wouldn't have really been a reason to take it with you. Like, it's not like having an iPhone today.
Right.
Where, like, you can just pop it out and take a picture. Like, taking a picture of, like, a football game is not going to just randomly happen on a flip phone. Like, it wasn't used for documenting purposes like they are now. So, like, my first phone was a slide phone. It did have a camera on it, but, like, I didn't, like,
Not a crazy big
just
picture.
pop it out. So just, like, take pictures of everything.
Yeah.
Like, I might pop it out and take, like, one picture.
Yeah.
So, I mean, I don't know. It is kind of surprising, but also kind of not at the same time. But
Right,
it is
no,
hard
it
to
was.
know, like, when it was. I would say, like, the late, like, thousands, like, 2000s, like, probably, like, 08 to, like, 12, I would say, somewhere in there. Because iPhones got super duper popular. Like, an iPhone obviously was a thing when I got
wasn't
my
like that
first
big a
phone.
little bit, right?
But they were on, like, the iPhone 3 at that time.
Oh, I had the iPhone 3. It was my uncle's and he gave it to me and I was like so excited.
Yeah, I got the iPhone 5, I think. I think the 5 is when they went to a thumbprint lock.
Yeah.
So that's the first one. Like, I got that one. I got a rose gold one. And my Bible teacher, we did this called Pop Culture Friday, and it was we were talking about, like, just different things that were going on in the world, and he straight up said, and he didn't have a clue, but he said, these people getting these gold iPhones are sinners, because all they're caring about is getting something that's, like, worth a lot of money to show off and stuff. It's like an idol. Like, he was turning it into things like, and everyone in the class knew that I was, like, on a wait list to get this phone, like, because I wanted the rose gold color. Like, he
Just
didn't
like
understand that it wasn't made of gold.
Right. Just the color gold.
It was literally just a color. He did not understand that concept. And so everyone in the class was laughing, and he was like, I'm going to guess by your reactions that someone in here has one. And I was just like,
Like,
and then somebody else popped in and was like, it's not made of gold. You do know that, right? He was like, it's not? I was like, do your research before you're gonna call someone out like that. Like, what?
I
Yeah, I
bought
don't
my
remember
first
that,
one off
Bruce.
Amazon. It was my first phone, and I saved up so much money, and it broke like not even a few months after. I just remember like being so excited because it came the day before I was supposed to go to Tennessee for Thanksgiving. I was like, oh my gosh, this is gonna be like the best trip yet.
And then you broke it.
It broke like 2 months later.
Oh my
I
goodness.
have a friend that's been through 15 different phones because he's just broken them. He broke one in like 30 minutes after he got it. They left his store, and he did like he flipped or something in the air or something like that, or spun around. It just like fell out of his pocket and it just broke on the pavement.
That happened to me. I did a spin in my iPhone 6. That's how it
Slipped
broke.
out.
It flew out of my back pocket.
You just dropped your phone anyways. You remember when we were at William's house and you were just holding it and it just like slipped out
Oh,
onto the
yeah.
ground?
It was bad. Like I had an iPhone 8 and there was literally a chunk out of it. And I was like, Dad, please, like just, I promise the next one I'll keep care of. And he bought me like a screen protector, this like
You didn't have a
Audiobox
screen
case.
protector before?
Well, I had one, but like then it broke and then I just never put one back. And he was like, Virginia, like if it starts breaking, you need to tell me. Like I'm not letting you take this case off. Just like, okay.
That's funny.
Alright.
All right. So our sample proportion then would be what?
Wait, 243? Wait.
Well,
243 on it.
yes, but what is that number representing?
People with cell phones?
Yeah, specifically at the game. So the proportion of students at the game who had a cell phone. And we could figure that number out. It would just be 243 out of the 2883, which would be, it's going to end up being 8.4%. So 8.4% of students had a phone at the game. Just, yeah, definitely not realistic for today.
Yeah, I feel like people wouldn't leave without it.
So then can we create a confidence interval? We need to look at our condition. So are these things independent?
Yes.
Yep. What about random?
No.
Yes.
Well, yeah.
Sort of.
I mean, they're asking like all the students, it sounds like, that came to the game. So I would say it's probably a representative sample of all students at least. So random, we don't know, but representative sample. What about 10% condition? Is this less than 10% of all students with the phone?
Yes.
And then success failure, N times P is 0.084, which is that number we just found, times 2883, which is 242. And then N times Q is 1 minus the 0.084 times the 2883, which is 2640. Both of those are greater than 10. So yes, we can create a confidence interval. All right, so this thing that here that says confidence interval, this is just where we're going to write what that would look like for just like a generic. So it's the statistic plus or minus the critical value, and I'm going to write it in symbols also, times the standard error. Now, critical error times standard error is margin of error. So this is a formula you want to make sure you're familiar with. Now, confidence interval in symbols is p hat plus or minus z star times the square root of p hat q hat over n. So our next statements are true or false statements, and we're gonna explain like why they are what they are within those as well. So several factors are involved in the creation of confidence intervals. Among them are sample size, the level of confidence, and the margin of error. Which statements are true? For a given sample size, reducing the margin of error will mean a lower confidence. What do you think? Basically, just do you think it's true or false?
I want to say true.
True.
Virginia was gonna say false, and I shook my head that it was true.
What can I say?
All right, so it is true. The interval, and I'm gonna put like the y behind it just so that y'all know why. So the interval will be smaller. So we will be less confident that we capture the true proportion. So the smaller the interval, the less confident. The larger the interval, the more confident. Which makes sense because if it's a bigger interval, then obviously we're more likely to end up with the number we're actually working on to be part of it. The next one. For a certain level of confidence, you can get a smaller margin of error by selecting a bigger sample.
False? Wait,
Think about your formula,
which one?
like for how you would find like the standard deviation. What's going to happen if your sample size is bigger?
It's going to be more confident, right? Just because you're getting more information.
Further away.
What's true about our standard deviation if our sample size is larger? So if I'm dividing it by a bigger number, what's true about? So this is true. A larger sample size means a smaller standard deviation. For a fixed margin of error, smaller samples will mean lower confidence. This one's probably a little harder. Virginia's just gonna keep saying that both until I tell her which one it is.
I'm gonna go with false.
I'm going to go with true again.
Am I wrong again?
You set. It's true.
Yes.
I haven't got a single one right. Okay, the next one's gotta be false.
Smaller samples have more variability. So we will be less confident in capturing the true proportion. For a given confidence level, a sample 9 times as big will make the margin of error 1/3 as big.
False. True. False.
Virginia is back and forth again. Think about the formula. If your sample size is 9 times as big,
Oh. Wait.
what happens if I do this?
And it'd be, wait.
Oh, no, it makes it 3 times. No. Wait.
1/9 is big.
It's the square root of 1/9, which is what?
1/3.
True.
So it's also true.
Oh, man.
So you made all these true.
To prove a point that every question is independent of the next one.
Oh.
There's a lesson in everything.
The square root of p hat q hat over n, if I put in the 9, so I'm just doing what I basically did up there for the reasoning, but p hat q hat over 9n would be 1/3 times the square root of p hat q hat over n.
It's always a little suspicious when they're all the same answer.
Oh, always.
Yeah.
Like they're half.
But this
But
is
it's a-
stats class, so
it's a
I'm
fake
proving a point.
But like when you know the stuff, then it's like it makes you second guess if you really know it or not.
Yeah.
Isn't that weird?
They can't all be the same answer, right?
Or it's like, I can't have 3 C's in a row.
Why do we do that? Because I feel like there's so many tests where it is like 3 C's in a row.
Yeah.
Like you have 17 multiple choice questions, 16 of them are C.
Oh, that would suck. I would hate that.
I had a teacher one time that did ABCD, ABCD, ABCD,
Oh, so you just knew that.
ABCC. So people that just thought that it was gonna keep following the pattern, they just started. Yeah.
I probably would.
What if someone was just like messing around guessing and like ended up getting them all right? Like, except for that one, of course.
All right, this one we will use our calculator for. When we do the conditions, just for the sake of time, I'm just gonna just put a check, like if it does or doesn't like meet the conditions as we talk about them. I won't write them all out, but all right. So direct mail advertisers send solicitations or junk mail to thousands of potential customers in hope that some will buy the company's product. Sometimes, literally, I've seen the mailman with just a pile of junk mail, and they just decide who gets what.
Oh.
Like, it doesn't actually have, like, an address. It's just, like, a flyer that just gets thrown in your box. Anyways, just thought that was interesting. The acceptance rate is usually quite low, meaning, like, basically people don't actually respond or buy whatever was sent out. Suppose a company wants to test their response to a new flyer and sends it to 1,000 people randomly selected from their mailing list of over 200,000 people. So 1,000 out of 200,000. They get orders from 123 of the recipients. So 123 out of the 1,000 actually purchase something. Create a 90% confidence interval for the percentage of people the company contacts who may buy something. All right, so first, our P hat is that 123 out of 1,000 that I was just saying, which is just a lovely 0.123. All right, so let's look at the conditions. Are these people independent?
Yeah.
Yeah.
Yeah. One person getting it or not getting it or responding or not responding does not affect the next. Are they random? Yep, they specifically tell us that they were randomly selected. 10% condition, is this less than 10% of all the people? Yep. And success failure, if I take this number and multiply it, it's obviously both of them are going to be greater than 10. So I'm just going to note that conditions are met. All right, so I can do this confidence interval by hand, or I can use my calculator to do the interval as well. So I'm going to show you both ways so that we have it. So by hand, and the big thing is you definitely need to know how to set it up by hand, because what they typically do is multiple choice questions will give you a confidence interval set up, and you have to be able to pick which one is the right one set up. As like that's how they typically end up testing this stuff. So the confidence interval is equal to P hat, which is 0.123, plus or minus. Now, the z-star for 90% is, because I don't think we had this one, is 1.645. Okay, so for 90%, z-star is 1.645, so that's what's going here. So that's another one of those numbers you're going to need to know. We've done the one for 95, I think is the one I gave you. So you have 90, 95, and there's one other one that's like 2 something that you'll need to know as well, but I'll get there when I have to always refresh every year on which one's which so that I don't misquote. Anyways, and then this is times the square root of 0.123 times q, which is 0.877, I think. Let me verify that I have that right. 1 minus 0.123. Yep. Over the sample size, which is 1,000.
That's 0.877.
Yeah. So this is just the setup, okay? The actual interval, then, I would have to do 0.123 plus 1.645 times that, what's in that square root box, and then do the minus 1, and whichever one is smaller obviously goes on the left, whichever bigger goes on the right. And I would have, this would create a parentheses interval for me. But I'm going to do it on the calculator, so I'm, again, for the sake of time, not going to actually manually do that by hand. So I think I had put this in the notes, but the way we do this is stat, test, and then we're looking for one prop z interval. So it'll be one prop z int, and then we're going to type everything in and then calculate it. So one prop z interval of hold on, let me look at what it actually asks for before I start doing this. So let me do this so we can actually see what we're doing. So stat, test is all the way over, and then just arrow down. It's pretty far down there. It's just alpha A. Yep, one prop z interval. So there's all different ones. You've got to make sure you read closely what you're looking for. There's a 2 prop z interval. There's also a 1 prop z test and all kinds of different things. So you've got to make sure you pay attention to which one we're using for which situation. So right now, I need this 1 prop z interval. So it asks me for x, which is your sample size of 123. Then it asks for the total number of people that it went to, basically, so 1,000. I misspoke when I said X is the amount of people that, like, responded. N is the number of people that it went to. So that's your actual sample size. X is the number of people who respond, or whatever the thing we're trying to find is. Then the C level is your confidence level. So in this case, it is it's 90 or but you have to put it in as a decimal. So 0.9. And then we're going to hit calculate. And it comes up and it gives me this interval here. So it produced an interval. And if I did the other thing by hand, I would get this same thing. Okay. Did I type something in wrong? Hold on a second, because that's not... Why did I type in 700? This number is not right. Did I really type in 700? I don't know how I did that. All right. Okay, there we go. So this would be... 0.106 to 0.140, or you can also write it as 10.6% to 14%. Either way is fine, but we'll finish going over what this actually means tomorrow, and then a couple of the examples for tomorrow are actually shorter, so we may finish up tomorrow, we may have to finish up on Wednesday, and then y'all have some time to work on Wednesday also on the homework problems, but that's it for today.